Yes or no? Can you hear me? अंकुश महाले सर आवाज नाही येत आहे. Now it is coming. Yes. Suprit is saying yes. येते का आवाज सगळ्यांना? किसको किसको सुनाई दे रहा है? यस. वेरी गुड. ओके चलो. Sakshi is saying sir now it's audible. Okay, no problem. So सुप्रीत विक्रम ठीक है चलो. So we were talking about the valence bond theory and application of valence bond theory to the different types of compounds. For example, tetrahedral compounds, square planar complexes, trigonal bipyramidal, and octahedral complexes. In the last lecture, that is Monday's lecture, we have seen application of valence bond theory to the tetrahedral compounds and square planar complexes. Okay. In today's lecture, we will see the application of valence bond theory to the TBP, that is trigonal bipyramidal and octahedral compound. Trigonal means trigone is there and at the center of that trigone metal is present. Okay, and above the trigone one ligand is there and below another ligand is there, so that geometry is called as a TBP geometry, trigonal bipyramidal, and hybridization shown by this geometry is DsP3. That means 1d orbital, 1s orbital and 3 p orbitals are involved in hybridization. Okay. In the d orbital, maybe dx square minus y square and z square will be involved in bonding. Yes, there is only one s orbital which is spherical shape. No specific symbol is there for s orbital, and 3p orbital, that means px, py and pz. These 3p orbitals are involved in the DsP hybridization. Okay. So today we will see the some examples of DsP3 hybridization, that is trigonal bipyramidal complexes. Okay. So now first we will start with TBP geometry. Okay. Yes or no? Are you ready? बोलो. ठीक है. यस और नो? कौन कौन तैयार है आज के टॉपिक के लिए? यस. अंकुश, प्रज्ञा, प्रिया, रोहन, विश्वजीत. ठीक है. So we will start. So first we will start with this trigonal bipyramidal complexes. First we will start with this trigonal bipyramidal complexes. ठीक है. And these complexes or this geometry, it shows two types of hybridization. कौन से तो दो types है. DsP3 is first type and second one is sp3d. ठीक है. So these two types are there. Trigonal bipyramidal complexes can show two types of hybridization. First one is DsP3 and sp3d. That means one d orbital is involved, one s orbital is involved and 3 p orbitals are involved. Total it will give a DsP3 hybridization. Okay. So first we'll start with the type number 1, that is DsP3 hybridization. Okay. Okay. So this DsP3 hybridization, its example is FeCO5, which is a neutral compound. Charge on this compound is 0. Okay. So it is a neutral compound, and IUPAC nomenclature of this compound is here. Carbon monoxide is ligand. 5 ligands are there. 5 ligands are there. So pentacarbonyl ion, oxidation state of iron is 0. Very simple. Okay. So first we will start with its atomic number. Fe atomic number is 26 and its electronic configuration. Now I will write only valence shell electronic configuration. Valence shell electronic configuration is 4s2 3d6. This is the valence shell electronic configuration. ठीक है, 4s2 4s2 3d6. Now in this oxidation state of iron is also 0, so it will show 4s2 3d6 electronic configuration only. ठीक है, yes or no? The valence shell electronic configuration is 4s2 3d6. Valence shell electronic configuration is 4s2 3d6. कैन यू हियर मी? आप लोगों को अच्छे से स्ट्रीमिंग हो रही है या नहीं? बिकॉज आई कांट सी योर चार्ट. हो रही ना? ओके, नो प्रॉब्लम. ठीक है, चलो. सो देन we will write the electronic configuration 4s2 here. 3d6 is this. 3d6, that means 6 electrons you have to fill. 1 2 3 4 5 and 5 and 6. Then 4s2 is there, so this 4s2 electrons will, and this 4p 0 is there. So this is the box diagram of Fe2 plus. ठीक है, 3d6 4s2 4p0. Now the ligand of this ligand is in this compound. The ligand is carbon monoxide. It is a carbonate, and it is which kind of ligand? It is a strong ligand, weak ligand or average ligand? Please tell me. कार्बन मोनोऑक्साइड कौन सा टाइप का लिगेंड है? टेल मी. कार्बन मोनोऑक्साइड, द टाइप ऑफ लिगेंड इज, कौन सा टाइप का लिगेंड है? कौन से टाइप का लिगेंड है कार्बन मोनोऑक्साइड? कैन यू हियर मी? ग्रीशा ने बोला है स्ट्रॉन्ग लिगेंड. ठीक है, सो कार्बन मोनोऑक्साइड इज स्ट्रॉन्ग लिगेंड. एंड स्ट्रॉन्ग लिगेंड क्या करता है? स्ट्रॉन्ग लिगेंड will do the pairing. When strong ligand is present, pairing of the electrons which is present in this compound will take place. ठीक है, so carbon monoxide is there, so it will pair the electrons. Now what will happen? These electrons will go in this. These electrons will go ठीक है, so this electron will go in this. This electron will go in this, and these two electrons they will go in this. So I will write here. So 1 2, here pairing will take place. Then here also pairing will take place, and here in this fourth d orbital 4s2 electrons will go in this. So pairing of the electrons will take place. So what will happen? The pairing of electrons will take place here. Due to what? Due to the presence of carbon monoxide, which is a strong ligand. Due to the presence of carbon monoxide and which is a strong ligand. ठीक है, I can't see your chart. So what will happen? The pairing of electron will take place. What will happen? the pairing of electrons will takes place because of presence of strong ligand, because of presence of strong ligand. I think some problem is there. Some problem is there. ठीक है. Now it is okay. Okay, now it is okay. Yes. So what we will, क्या देख रहे थे हम लोग, यहाँ पे पेयरिंग हो जाएगा, यहाँ पे pairing will take place. So these electrons will get into this orbital, these electrons will get into this orbital, and these two electrons from 4s orbital will go into the 4th d orbital. So this condition will take place due to the presence of what? Due to the presence of carbon monoxide ligand, which is a strong ligand. Due to the presence of carbon monoxide, which is a strong ligand. ठीक है? Yes or no? Yes or no? ठीक है? So in the next assumptions क्या है? So here the coordination number of metal is 6. Coordination number कितना है? Sorry, 5. Coordination number is 5. So that means 5 ligands are there, and one ligand donates 2 electrons. So total 5 into 2, total 10 electrons. Total 10 electrons is available. Okay. Now in this 10 electrons we have to fill into how many orbital? 5 orbital. Because of what? Because of the coordination number of this complex is 5, and metal should have at least 5 vacant orbitals so as they can accept the electrons from the ligands. No, so here 5 orbitals are there: 1, 2, 3, 4 and 5. Now you can fill the 10 electrons into these orbitals: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 electrons. So what will happen? This 1d orbital, 1s orbital and this 3p orbital, they will undergo process, that is sp3, undergo process, that is hybridization. We will give a hybridization dsp3. We will give hybridization dsp3. ठीक है? Now see the number of unpaired electrons. How many number of unpaired electrons is present in this compound? कितने हैं? Number of unpaired electrons. Can you see any unpaired electrons in this compound now? Tell me. No. 0 unpaired electrons. 0 unpaired electron. 0 unpaired electrons. That means the complex is diamagnetic. That means what? That means this complex is diamagnetic. Yes or no? The complex is diamagnetic. Because of what? Because of there is 0 unpaired electrons. There is 0 unpaired electrons present. Now tell me its magnetic moment. Tell me the magnetic moment now. 0 unpaired electrons. कृष्ण प्रिया ने बोला है, ठीक है. Now tell me the magnetic moment. Magnetic moment will be 0. ठीक है. Magnetic moment will be 0. So mu s is equal to 0. Because of what? Because of 0 unpaired electrons. ठीक है, okay, चलो. Now see in this clear diagram, now you can see FeCO5 pentacarbonyl ion is there. F is 26, atomic number of F is 26, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6, 4s2, 3d6, correct. Now this is the valence cell electronic configuration, 4s2, 3d6. Now draw the box diagram. 3d6, 6 electrons in 3d orbital. Here 2 will be there. 4s2, 2 electrons in 4s orbital, and 4p orbitals are vacant. Okay. Now what will happen? Due to the presence of carbon monoxide ligand, which is a strong ligand, and if strong ligand is present, then pairing of the electrons, pairing of the metal electrons will take place. So these electrons will go into this orbital. This electron will go into this another orbital, and these two 4s electrons, they will go into the 4th d orbital. So these conditions will be there. So due to the carbon monoxide strong ligand, the pairing of the electron, metal electron takes place. Okay. Then here 3d8 will be there. Now 3d8 will be there. Then what will happen? Next step, total 5 carbonyls are there. Total 5 carbonyls. Each carbonyl will give 2 electrons. So total we have 10 electrons. 10 electrons we have to fill in the complex. So this 10 electrons we have filled. Okay. 2, 4, 6, 8 and 10. Then what happen? Then these orbitals will undergo process called as a hybridization and will give you a dsp3 hybridization. dsp3 hybridization. Then the number of unpaired electrons present are 0. That means this complex is diamagnetic. Okay. And experimental as well as theoretical magnetic moment of this complex will be 0. That means experimental and theoretical magnetic moment of this complex is 0. So this is the first type. ये first type था, that is dsp3. कौन सा type था ये? This is the first type, that is dsp3. Why? Because here one d orbital is involved, one s orbital is involved, and 3p orbital is involved. So 3 dsp3 hybridization. dsp3 hybridization. Okay, good. Then we will see the next type, that is sp3 dehybridization. The next type is sp3 dehybridization, means one s orbital, 3p orbitals, and one d orbital is involved. An example is CuCl5 3 minus, that is pentachlorocuprate. The atomic number of this compound is pentachlorocuprate. Okay. Then we will write down the atomic number. Atomic number of copper is how much? कितना atomic number copper का बोलो? The atomic number of copper is 29. Last lecture में हम लोगों ने देखा है. Atomic number of copper is 29 and its valence cell electronic configuration is 4s1 3d10. 4s1 3d10. It is called as the anomalous electronic configuration. It is due to get a stability because of, according to the rule, those orbitals which have fully filled electrons or full electrons are present, then that orbital is stable. So to get extra stability, one electron from 4s orbital will go into the 3d orbital and it will form a 3d 10 electronic configuration. Now here 3d 10 will be there, okay, and 4s 1 will be there. So we will fill the electrons now. How many electrons are present in the orbital? 10 electrons. 1, 2, 3, 4, 5. Okay. 6, 7, 8, 9 and 10. Then 1 electron. Then ठीक है, तो चलो डी ये तो हो गया कॉपर in 29 zero oxidation state. Here oxidation state of copper is how much? +2. Oxidation state of copper is +2. That means copper 2 plus, it will have electronic configuration 4s0 3d9. It will have electronic configuration 4s0 3d9. 2 plus charge means 2 electrons are removed from the copper and these 2 electrons are removed from the s and d orbital. One electron will go from s 4s orbital and another electron will go from 3d orbital. So it will give 4s0 3d9. Now here one electron will be less, here this electron will be less. Okay, so this will be the box diagram, that is 3d9 here. Here now 9 will be there, 3d9 4s0, 3d9 4s0. Okay, yes or no? Then 4p 0. Now see here, copper is central metal atom and chloride is a ligand, and this chloride is which kind of ligand? Chloride is which kind of ligand? It is strong ligand, weak ligand, or average ligand? Tell me. It is a weak ligand, and due to the weak ligand do not uh, when weak ligand is present, pairing of the electrons will not take place. What will happen? Pairing of the electron will not take place. So now coordination number कितना है यहाँ पे? Here also the coordination number is 5. That means according to the first assumptions you should have 5 vacant orbitals. So here I will write 1 2 3 4 5 6 7 8 9 electron. Here I will write 3d 9 electron, 4s 0 4s and here 4. ठीक है. So total how many electrons we will have? 5 into 2 10 electrons we have. कितने electrons है हमारे पास? 10 electrons. Now here how many vacant orbitals are there? 1 2 3 4. Only 4 vacant orbitals are there, and according to the first assumptions of Valence-Bond theory, metal should have the vacant orbital equals to its coordination number. Now coordination number is here 5. Coordination number 5. तो कितने होने चाहिए? 5 vacant orbital होने चाहिए, but here only 4 is there. So that's why this compound uses 1d orbital from 4d energy level. 1d orbital from 4d energy level. So this 4d here comes into picture. This 4d यहाँ पे use किया जाता है. So now how many orbitals are there? 1 2 3 4 and this one from 4d level. So fill the 10 electrons now. 1 2 3 4 5 6 7 8 9 10. Now what will happen? This 1s and 3p and 1d, they will undergo hybridization process and they will give sp3 dehybridization. They will give sp3 hybridization. Okay, 1s that is 4s, 3p that is 4p and 1d orbital, and that is from 4d energy level. Please remember in this case the d orbital involved is not from 3d level, it is from the 4d energy level. Okay, so that's why its hybridization is sp3d. That's why it is hybridization is sp3d. Now you got the difference between this dsp3 and sp3d. समझ में आया? What is the difference between these two types? First one we have seen, that is dsp3, and this second one is sp3. Now what is the difference? In the first case, that is dsp3, d orbital is from 3d level. In the first case, d orbital is from 3d level, correct? And in this sp3d, the d orbital is from 4d level. ठीक है? In पहले केस में क्या था? n is equal to, n is what? N is called as a principal quantum number, that n is equal to 3, and in this case sp3d the n is equal to 4. This is the difference. Now see the number of unpaired electrons. Only one unpaired electron is there. Only one unpaired electron is there. That means this complex is paramagnetic. एक unpaired electron से तो complex will be paramagnetic. ठीक है? Then its experimental magnetic moment is 1.73 bm. This is experimentally calculated by using the Gui's balance. Now you tell me the theoretical magnetic moment or calculated magnetic moment of this compound. You have formula. In the last lecture I told that formula. Put the value of n here. N is equal to how much? N is equal to 1 because of number of unpaired electrons in this, it is 1. So put the value in that equation and then tell me the theoretical magnetic moment. I will write here theoretical magnetic moment. You have to tell me the value of this. क्या है theoretical magnetic moment की value? Put the value. We have spin only formula, that is under root n into n plus 2 dm. Here n is equal to 1. Put this value. Take a scientific calculate it and tell me. 1.73. कृष्ण प्रिया ग्रीशा ने बोला है 1.41. 41 नहीं होगा. ग्रीशा एक बार फिर से कैलकुलेट करो. इट्स थ्योरेटिकल मैग्नेटिक मोमेंट इज, ग्रीशा ने अभी बोला है 1. नो, इट इज नॉट 1. सो 1.73. that means this theoretical and magnetic and calculated magnetic moment, they are nearly same. So we can say that the observed and actual geometry of this compound is TBP. Sorry, yes, TBP, and hybridization is sp3d. Hybridization is sp3. ठीक है. Understood these two types of hybridization? Yes or no? ठीक है, एक बार फिर से देख लेते हैं. आप लोगों ने अगर लिखा नहीं तो यहाँ पे लिख लो. You can write down this example. First you have to write the copper, its atomic number you have to write, then write down the electronic configuration. Valence cell electronic configuration is here 4s1 3d10, and in copper 2 plus what will happen, 2 electrons will get removed, and these 2 electrons will get removed from 4s and 3d orbital, and it will give 4s0 3d9. then put this 3d9 electrons or draw the box diagram, then do the uh, hybridization, that is 4s 4p and 4d orbital will undergo hybridization, will give sp3d hybridization. One unpaired electrons, that means complex is paramagnetic. correct, ये भी हम लोगों ने सही बोला था. complex is paramagnetic because of presence of one unpaired electrons. Then experimental magnetic moment is 1.76 and calculated magnetic moment or theoretical magnetic moment is 1.73. that means these two values are closely uh, uh, nearly same. So we can say that observed and actual geometry of this complex is trigonal bipyramidal and hybridization is sp3d. ठीक है. So if you want you can write down this or you can take a screenshot. simple. ठीक है. You can take a screenshot also, no problem. Okay, ले लिया है 1 2 3. चलो ठीक है. So we'll go to the next type of geometry, that is octahedral complexes. Next type of geometry, that is octahedral complexes. Octahedral complexes are here. I have shown the structure of octahedral complexes. ठीक है. Here metal is present at the center, then one square is there. Here 4 ligands are there, and at the center of that square metal is present, and another ligand is above the plane and sixth one is below the plane. So total is ml6. total it will give ml6. ठीक है. Now this octahedral complexes again shows two types of hybridization, d2sp3. again these octahedral complexes shows two types of hybridization, d2sp3 and sp3d2. d2sp3 and sp3d2. now what is the difference, we will see one more time. ठीक है. now here in first case 2 d orbitals are involved. 2 d orbitals are involved. Which 2 d orbitals are involved? dx square minus y square and dz square. ठीक है. and these orbitals are from n minus 1 cell. These orbitals are from n minus 1 cell. Then 1s orbital is involved. 1s orbital is involved. n orbital there is no such specific symbol for s orbitals, and this here s orbital is from nth cell. This s orbital is from nth cell, and three p orbitals are involved. Three p orbital. Which three p orbital? Px, py, and pz. These three p orbitals are involved, and they all are from nth cell. कौन से सेल में? nth cell में. Here d orbital they are from n minus 1 cell, and s and p are orbital from n cell. Now here also same, 2d orbitals are involved. Which 2d orbitals are involved? Dx square minus y square and dz square. And now here these d2d orbital they are from n cell. They are from nth cell. Then 1s orbital is involved. 1s orbital again here it is from n cell, and 3p orbitals. 3p orbitals which? Px, py and pz, and they all are from nth cell. ठीक है, समझ में आया the difference between these two compounds, or these two hybridization? What is the difference? In first case, that is d2sp3, d orbitals are from n minus n cell. D orbitals are from n minus n cell, and in the second case 2d orbitals they are from n cell. This is the difference. So how it is n minus 1 and n cell, that we will see while solving the examples. ठीक है, वो आप लोगों को अच्छी तरह से समझ में आएगा जब हम लोग एग्जाम्पल सॉल्व करेंगे तब तक के लिए सिर्फ इतना याद रखो कि d2sp3 में जो d orbitals है that is from n minus 1 cell, and in the second type sp3d2 में 2d orbitals they are from n cell. ठीक है, एक बार देख लो. Here also, here I have given now 2d orbital they from n minus 1 cell, and 1s and 3p, that is px, py, pz, they are from n cell, and here n minus 1 cell, and here all the orbitals they are from n cell. They are all from nth cell. ठीक है, अंडरस्टूड? यस और नो? समझ में आ रहा है? टेल में, समझ में आ रहा है आप लोगों को? नहीं आ रहा है? You can also take a screenshot. If you don't have pen and notebook, आप लोग कैसे बाहर बैठे हो, गार्डन में बैठे हो, आपके पास पेन नोटबुक नहीं है, तो you can take a screenshot of this. What is the difference between D2sp3 and sp3d2 hybridization octahedral complexes? समझ में आ रहा है? Yes or no? ग्रीशा, चेतन, कृष्ण प्रिया, अमित सब बोल रहे यस सर. ठीक है, व्हाट अबाउट अदर्स? बाकी के लोगों का क्या? रोहन, स्नेहल, वैभव, कोमल. ठीक है, अब आप सब लोगों को समझ में आ रहा है. ठीक है ना? नाउ अगर आपको ये समझ में, साक्षी, प्रिया, प्रियंका, प्रज्ञा, ठीक है, मृण्मयी इज also saying yes sir. Now listen my question carefully. Now my question is, there are 5d orbitals, correct? 5d orbitals are there. Which 5d orbitals are there? dxz, dyz and dxy. These three orbitals, dxz, dyz and dxy, and dx square minus y square is there, and dz square. Now out of these, Vishwajit is saying understood. ठीक है, okay, good. Now Vishwajit, answer my question. There are 5 orbitals, 5d orbitals, dxy, dxz, dyz, and dx square minus y square and dz square. So out of these 5 orbitals, only dx square minus y square and dz square, these two orbitals are involved in the bond formation. ठीक है. Now my question is, why only these two orbitals are involved in bond formation, and why not dxy, dxz and dyz? Why they are not involved in the bond formation? Now tell me if you understood. You tell me now. बोलो जल्दी. Or you can guess. You can guess. अपना दिमाग लगाओ, सोचो, अपना दिमाग लगाओ और बोलो. Why only dx square minus y square and dz square are involved in the bond formation? That is coordinate bond formation. Why not dxy, dxz and dyz? Because they are at the lower energy level. Grisha is saying because they are at the lower energy level. No, 5d orbitals, they will have same energy because of they are degenerate. They all 5d orbitals has the same energy, no difference in the energy. It is explained in crystal field theory. What is explained in crystal field theory? No. Who told you it is explained in crystal? Yeah, we can explain in crystal field theory, no doubt. बट व्हाट इज द रीजन? हाँ, एक्सप्लेन इन क्रिस्टल फील्ड थ्योरी में हम लोग देखेंगे, वहां पे मैं बोलने वाला हूँ आप लोगों को. एंड दे lie along the axis. Correct, very good Grisha, because of they lie along the axis. ठीक है. एंड व्हाट अबाउट अदर्स? ग्रीशा ने बोला है कि dx square minus y square and dz square they lie along the axis. Correct. And what about others? And what about others? dxz, dyz and dxy, they are at last position. Suprit is saying they are at last position. No, position does not matter. We cannot say these two orbitals are the last position. We can say they are first two also. We cannot differentiate because of energy is same. We cannot differentiate them on the basis of energy. Grisha ने थोड़ा सा मुझे सही बोला, because they lie in the along the axis. And what about others? एंड दे आर, प्रज्ञा अभी प्राची बोल रही है कि दे आर इन बिटवीन द एक्सिस. ठीक है. ग्रीशा ने भी बोला है कि दे लाई इन बिटवीन द एक्सिस. नाउ करेक्ट, वेरी गुड, अच्छा बोला आप लोगों ने. डी एक्स स्क्वायर माइनस वाई स्क्वायर एंड डी जी स्क्वायर, दे हैव देयर लोब्स along the axis. Their lobes are along the axis. And other dxz, dyz and dxy, their lobes are in between the axis. ठीक है. First three dxy, dxz and dyz, their lobes are in between the axis. In between the axis. And these two, dx square minus y square and dz square, their lobes are along the axis. Now, क्या फर्क पड़ता है? इन दोनों के लोब्स along the axis है और उनके in between the axis है, तो क्या फर्क पड़ता है? क्यों नहीं हो रहे हो इन्वॉल्व? वो तो आपने सही बोला है कि उसके लोब along the axis है और अदर तीनों के इन बिटवीन द एक्सिस है. ठीक है भाई है, लेकिन क्या फर्क पड़ता है? क्या फर्क पड़ता है? उनके लोब्स along the axis है और उन तीनों के लोब्स इन बिटवीन द एक्सिस है. सो व्हाट? ग्रीशा थोड़ी क्लोज जा रही है आंसर के. आई वॉन्ट आंसर फ्रॉम हर ओनली नाउ. तो क्या फर्क पड़ता है यार? एक के तो एक्सिस के अलोंग है और बाकी तीनों के इन बिटवीन द एक्सिस से, तो क्या फर्क पड़ने वाला है? बोलो, अपना दिमाग लगाओ भाई, सोचो जरा सा. Nobody knows. Very simple है. Yes, Krishna Priya. Now you can tell me. You must know the answer. Along the axis it becomes easier for the ligand to approach metal. No, not at all. Now you people go to the CFT, that is crystal field theory, and read there. I think it is not, it is maybe चैप्टर में नहीं होगा उसमें, ये अपने दिमाग लगाने की जरूरत है, ठीक है। जो कुछ भी आपके पास नॉलेज है वो आपको अप्लाई करना है, देन यू विल कम टू द आंसर। ये किसी बुक में नहीं होगा, आई एम टेलिंग यू, ये किसी बुक में नहीं होगा। नोबडी नोज, मैं बता दो आप लोगों को, यस और नो, बताऊं या आप लोग बोल रहे हो? बोलो जल्दी। आई एम थिंकिंग सर। कृष्ण प्रिया is saying I am thinking sir. Can I tell you now? Yes or no? dz square has one lobe along the z axis. Shapes? No. Repulsive forces are less along the axis. No. Chaitanya, all our others are having no. Okay, now I will tell you. Now listen carefully. So what happens? First thing क्या होती है? First ligand donates electrons to the metal. फर्स्ट थिंग यही होती है ना कि लिगैंड के पास जो कुछ भी लोन पेयर है, दैट लिगैंड डोनेट्स हियर, ligand donates a pair of electrons to the metal because of ligand is acting as a Lewis base and metal is acting as a Lewis acid, ठीक है। So after the donation of electron, here coordinate bond will get formed. Why coordinate bond will get formed? Because two electrons are donated by the ligand only, ठीक है, and this bond is called as a sigma bond. This bond is called as a sigma bond. Now why this bond is called as a sigma bond? Because axial overlapping is there. Because of what? Because axial overlapping is there, and these orbitals, they have their lobes along the axis, and if they are along the axis, then only they can overlap with ligand, and those they have their lobes in between the axis, so they cannot have head-on overlapping, they cannot form a sigma bond, they will form a pi bond, so these dxz, dyz and dxy will form a pi bond and not a sigma bond, and only these two orbital they have their lobes along the axis, then only these two orbital can form a sigma bond. This is simple reason behind this, ठीक है ना। Because of what? Because of the first sigma bond will get formed. This is the assumptions of valence bond theory. And sigma bond, when we sigma bond will form when axial overlapping is there, when head-on overlapping is there. And कौन से axial overlapping हो सकती है, कौन से ऑर्बिटल की हो सकती है axial overlapping? जिनके lobes along the axis है, और इनके lobes तो in between the axis है, they will form a pi bond, ठीक है। So simple reason is there, ठीक है। आप समझ में आया सब लोगों को? यस और नो? समझ में आया है नहीं आया? dx square minus y square dz square have their lobes along the axis, and along the axis है, so axial overlapping is there. If axial overlapping is there, then that bond is called as a sigma bond. If sidewise overlapping or lateral overlapping is there, then that called as a pi bond. सिंपल है, ठीक है। समझ में आ रहा है? Yes or no? You can reply me in chat box. Yes sir. Now are saying yes sir, ठीक है। तो ये ध्यान में रखो। Why only these two orbitals are involved in bond formation? Because their lobes, because these orbitals have their lobes pointed along the axis, and along the axis है, that means axial overlapping will be takes place, and axial overlapping, that means that bond is called as a sigma bond, and dxz, dyz, dxy, they will form a pi bond. Okay, so this is the difference. Now what is the n minus 1 cell, what is n cell, that we will see while we discuss the problem. Okay, so first we will discuss this problem. First we will discuss this problem, that is type number 1 D2sp3. Type number 1 is D2sp3 hybridization, and example is CONH3 plus, and the IUPAC name is hexaamine. 6 amines are there, so hexaamine metal is cobalt 3 plus ion. ठीक है. Now कोबाल्ट का एटॉमिक नंबर कितना है? कोबाल्ट का एटॉमिक नंबर इज 27. इट्स वैलेंस शेल इलेक्ट्रॉनिक कॉन्फ़िगरेशन इज 4s2 3d6. ठीक है, so this is in zero oxidation state. now in this complex cobalt is present in 3 plus oxidation state. ठीक है ना, कोबाल्ट की ऑक्सीडेशन स्टेट कितनी है? 3 प्लस है. सो क्या हो जाएगा? 3 plus oxidation state means 3 electrons are removed. So 2 electrons will get removed from 4s orbital, it will become 4s0, and 1 electron will get removed from 3d orbital and it will become 3d5. It will become 3d5. Sorry, it will become 3d7 is here, and it will become 3d6. atomic number 27 है ना. 4s2 3d7, 4s2 3d7. cobalt in 3 plus oxidation state will show 4s0 3d6, 4s0 3d6, because of 3 plus charge means 3 electrons are removed. 2 electrons will get removed from s orbital and 1 electron will get removed from 3d orbital. So कितने थे? 3d7 थे, तो 3d6 रह जाएंगे. कितने रह जाएंगे? 3d6. ठीक है. देन नाउ फिल द इलेक्ट्रॉन्स इन दिस बॉक्स डायग्राम. 3d6 इज देयर, करेक्ट. यहाँ पे मैंने लिखा था 1 2 3 4 5 and 6. ठीक है. नाउ हियर लिगेंड इज अमोनिया लिगेंड. कौन सा लिगेंड है यहाँ पे? NH3 अमोनिया लिगेंड है. और ये अमोनिया लिगेंड कौन से टाइप के लिगेंड है? स्ट्रॉन्ग या वीक लिगेंड? सी इट. NH3 is strong ligand, weak ligand और average ligand. Tell me now. कौन सा ligand है? Tell me, ammonia is which kind of ligand? बोलो भाई, जल्दी से दिमाग लगाओ. मैंने फर्स्ट लेक्चर में बोला है आप लोगों को. कौन सा ligand है? अमोनिया इज एव्हरेज लिगॅन्ड. मानसीने सांगितलं आहे. ठीक आहे. अमोनिया इज एव्हरेज लिगॅन्ड. एव्हरेज लिगॅन्ड मीन्स those ligands can act as a but strong with cobalt. ठीक. Grisha is saying but strong with cobalt. It is average ligand. So forget about what is that. It is average ligand. Correct. Very good. Now average ligand का क्या खासियत है? They can act as a strong as well as they can act as a weak ligand. It depends upon the situation. Now situation कौन सा है? कि which metal is present? What is the oxidation state of metal? Now here, if ammonia ligand is there and cobalt in 3 plus oxidation state, then this ammonia ligand is acting as a strong ligand. This ammonia ligand is acting as a strong ligand in presence of cobalt 3 plus ion. In presence of cobalt 3 plus, ammonia is acting as a strong ligand. Originally it is a average ligand, but in cobalt complexes, when octahedral complexes is there, that means coordination number 6 is there, and cobalt oxidation state 3 plus is there, then this ammonia ligand is act as a strong ligand. It act as a strong ligand. So strong ligand means what? Strong ligand क्या करता है? Strong ligand electrons की pairing करता है. So these electrons will get into this orbital, and these electrons will get into this orbital. So I will write here 1 2 3 4 5 6. ठीक है. So This is because of the ammonia is acting as a strong ligand here. Now coordination number 6 hai, that means 6 ligands are there, 6 ammonia ligands, each ligands will give you 2 electrons, so 6 into 2 total 12 electrons we have. These are 12 electrons of ligand. किसके इलेक्ट्रॉन्स है 12 है. कोऑर्डिनेशन नंबर कितना है 6 है. सो अकॉर्डिंग टू द assumptions of valence bond theory, metal should have at least 6 vacant orbital है क्या 2 4 2 3 4 5 6 6 है. So we have 12 electrons, and 12 electrons we have to fill in 6 orbitals. So I will write here 1 2 3 4 5 6 7 8 9 10 11 12. So these electrons or these orbital they undergo hybridization and will give you, these electrons will undergo, this orbital will undergo hybridization and will give you 2d orbital is there, so d2, 1s orbital, so s, and 3p orbital, so 3p, so d2 sp3 hybridization. कौन सा hybridization हो जाएगा d2 sp3 hybridization because of these 2d orbitals, 1s orbital and 3p orbital will give you d2 sp3 hybridization. Now see the unpaired electrons. How many unpaired electrons are there? Can you see here? 0 unpaired electrons. Unpaired electrons is 0. The complex is diamagnetic. The complex is diamagnetic because of the Chetan is saying 0 unpaired electron. Correct. 0 unpaired electrons means complex is diamagnetic, and observed and calculated magnetic moment will be 0. Observed and calculated magnetic moment will be 0. So this is the first type. ठीक है, दिस इज द फर्स्ट टाइप D2 sp3 हाइब्रिडाइजेशन. ठीक है, एक बार फिर से देख लेते हैं हम लोग D2 sp3 हाइब्रिडाइजेशन. ठीक है, D2 sp3 hybridization. Example is CONH363 plus hexaamine cobalt 3 plus iron Iotech nomenclature. Cobalt atomic number is 27. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. This is valence cell electronic configuration 4s2, 3d7. Now cobalt 3 plus. 3 plus means 3 electrons are removed. 2 electrons will go from 4s orbital and 1 electron will go from d orbital, so it will become 4s0 3d6. Now fill the electrons here 4s0 3d6 1 2 3 4 5 6. Now here ammonia is acting as a strong ligand. I have told ammonia is acting as a strong ligand in presence of cobalt 3 plus, and when coordination number is 6, then what will happen, these electrons will go in this orbital and these electrons will go in this orbital, so there will be the, now these two orbitals are become vacant. Now total how many orbitals, 1 2 3 4 5 6, 6 orbital, 6 coordination number, 12 electrons we have to fill, so these 12 electrons we are filling now. Okay, then after the this filling of 12 electrons from ligands, these orbitals will undergo hybridization and will give you D2 sp3 hybridization. Will give you D2 sp3 hybridization. Now unpaired electron. What about unpaired electrons? 0 unpaired electrons is present. That means the complex is diamagnetic. Experimental and theoretical magnetic moment will be be 0 because no unpaired electron is present. Complex is diamagnetic. ठीक है, समझ में आ रहा है? ओके चलो, देन दिस एग्जांपल इज देयर. FeCN6 3 minus hexacyanoferrate 3 plus ion. ये आप लोगों के पास एग्जांपल है. नाउ you solve this example and tell me the number of unpaired electrons and whether the complex is paramagnetic or diamagnetic. आप लोगों को मुझे बोलना है. पेन नोटबुक लेके बैठे हो तो क्या करो, फर्स्ट व्हाट यू हैव टू डू, राइट द एटॉमिक नंबर ऑफ आयन. एटॉमिक नंबर ऑफ आयन इज 26. so write down its electronic configuration. iron ने in zero oxidation state. 26 means 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. this 4s2 3d6 is called as a valence cell electronic configuration. Now Here oxidation state of iron is how much? +3. Oxidation state of iron is +3. So write down the oxidation electronic configuration of iron in +3 oxidation state. +3 oxidation state means 3 electrons will get removed. That means 2 electrons will get removed from 4s orbital and 1 electron will get removed from 3d orbital. Okay? That means its valence shell electronic configuration will become 4s0 3d5. Now draw the box diagram. किए बॉक्स डायग्राम ड्रॉ, जल्दी से करो. Draw the box diagram and fill the 5 electrons in 3d orbital. 3d 5, 4s 0 is there and 4p 0. Now here cyanide is a strong ligand. Cyanide is a strong ligand. So in presence of this strong ligand, pairing of the electrons will take place. ठीक है, so pairing करो electrons की. Then the coordination number of this complex is 6. So metal should have 6 vacant orbital. count करो 6 आ रहे क्या, आने ही चाहिए. ठीक है, so coordination number 6. 6 cyanide ligands are there. 6 cyanide ligands means each ligands will give Grisha D2sp3 1 unpaired electron paramagnetic complexes. correct. ठीक है, 1 unpaired electron कृष्ण प्रिया ने भी बोल दिया है. ठीक है, चलो जिन लोगों को नहीं आया है वो एक बार देख लो. जिन लोगों ने सॉल्व नहीं किया है वो एक बार देख लो. FeCN63 minus 4s2 3d6 4s2 3d6 दिस इज इन जीरो ऑक्सीडेशन स्टेट. 3 प्लस में क्या हो जाएगा 4s0 3d5. then draw the box diagram, do the pairing. Why pairing will occur? Because of cyanide, and cyanide is a strong ligand. Because of cyanide ligand is present and this cyanide ligand is a strong ligand. So what will happen? And these electrons are from the ligand 6 cyanide ligand. It will undergo hybridization, that is called as D2sp3 hybridization. Why? Because 2d orbitals are involved, 1 s orbital involved and 3p orbitals are involved. So it will give a D2sp3 hybridization. correct, very good. Then the one unpaired electron complex will be paramagnetic. यहाँ पे paramagnetic होना चाहिए. complex is paramagnetic. experimental magnetic moment यहाँ पे experimental magnetic moment is 2.3. कौन कितनी है 2.3. now you tell me the calculated magnetic moment by using the spin only formula. calculate the magnetic moment and tell me the value of mu s. tell me the value of mu s. कितनी है mu s is what? वन 1.73. ठीक है, कृष्ण प्रिया Grisha is saying 1.73. so theoretical magnetic moment will be 1.73. so these are again nearly same. so we can say that the observed and actual geometry of this complex is octahedral and hybridization is D2sp3. hybridization is D2sp3. ठीक है. So the second type is remain now, that is sp3d2. sp3d2 hybridization octahedral का second type है, that we will see I think in the next lecture. for today we will stop here. ठीक है. for today we will stop here. The sp3d2 That hybridization we will see in the next lecture. Now, if you have any problem, any doubt, you can ask me. Yes, कुछ प्रॉब्लम है, डाउट्स है? Supriya Kumari saying okay sir. ओके थँक्स सर, नो डाऊट. चेतन म्हणतोय थँक्स सर, नो डाऊट. ठीक आहे. No doubt. Shall I stop the lecture now? Jay Ratnaparki is saying no doubt sir. Okay, that means you have understood each and everything from today's lecture. That's good. अच्छी बात है. अगर आप लोगों को कुछ डाउट है तो आप लोग मुझे गूगल क्लासरूम पे भी पूछ सकते हैं. विश्वजीत इज सेइंग नो प्रॉब्लम, थैंक यू सर. ओके चलो, सो शैल आई स्टॉप द लेक्चर नाउ? Sir, in FeCO5, Krishnapriya, FeCO5 complex, the electrons from 4s orbital went to the vacant d orbital. Sir, क्या प्रॉब्लम था कृष्णप्रिया का? लेट मी रीड. Where did the electrons get energy from? Go to FeCO5. FeCO5 कहाँ पे था FeCO5 हम लोगों का? Krishnapriya, that is an assumption to satisfy the hybridization and geometry. No, here electrons are de-excited, not excited. See, 4s orbital is there. If you see me, or I will this one. ठीक है, यही बोल रहे हो ना आप लोग? अभी आप लोगों को स्क्रीन पे दिख जाएगा. जस्ट गिव मी अ सेकंड, जस्ट गिव मी 1 सेकंड. दिख रहा है स्क्रीन पे? नहीं दिख रहा है, टाइम लग रहा है. ठीक है, ठीक है. नाउ अभी दिख रहा है. ठीक है. नाउ कृष्णप्रिया ने क्या बोला है कि दिस इलेक्ट्रॉन्स आर ट्रैवलिंग फ्रॉम 4s to 3d orbital. Now 4s electrons is higher in energy, and these 3d orbitals, they are lower in energy. And the higher energy 4s orbital, in presence of carbon monoxide, which is a strong ligand, electrons can go from higher in energy to the lower in energy to get a stability. And this is possible because of why? Because carbon monoxide is there, and carbon monoxide is strong ligand. Otherwise, if Cl was there, then these electrons in presence of Cl, उसकी pairing नहीं हो जाती. ठीक है. It is possible because of what? Because of carbon monoxide ligand is there. And this, if you talk about the energy, 4s is higher in energy and 3d orbital is lower in energy. So electron can come from higher energy to lower energy. There will be no need to provide the energy. ठीक है. अगर आपको हायर एनर्जी से लोअर एनर्जी पे आना है तो नो नीड टू provide the energy. So electrons are while coming from higher energy to lower energy, some energy will be emitted, some energy will be emitted or given out, and this happens because of what? Because of the carbon monoxide ligand, and which is a strong ligand. ठीक है, which is a strong ligand. ठीक है, समझ में आया कृष्ण प्रिया? देन और क्या था? That is an assumption to satisfy the hybridization and the geometry. Now Krishna Priya is saying yes sir, got it. Okay, no problem. Okay, चलो. ठीक है. Now चलो, तो we'll stop here. We'll meet next Monday. मे बी नेक्स्ट वीक आप लोगों के लेक्चर होने वाले हैं, नहीं पता नहीं, क्योंकि नेक्स्ट वीक TY के एग्जाम्स होने वाले हैं. मे बी हम लोगों को सुपरविजन की ड्यूटी रहेंगी. मे बी नेक्स्ट वीक पता नहीं, लेकिन कैसा स्केड्यूल है वो देखना पड़ेगा. ठीक है. सो नेक्स्ट वीक लेक्चर का थोड़ा नेक्स्ट एंड नेक्स्ट वीक थोड़ा प्रॉब्लम ही आ जाएगा आप लोगों का, क्योंकि एग्जाम ऑफ TY BSc के एग्जाम से लास्ट ईयर के BSc के है, MSc के भी है. ठीक है ना? ओके, चलो. सो इफ पॉसिबल वी विल मीट नेक्स्ट वीक. ठीक है. ओके, नाउ शैल आई स्टॉप हियर? ओके, चलो, बाय बाय. Pradnay Singh sir, when college is going to start? Sorry, I don't know. When government allows us, we'll definitely start college. ठीक है. बट आई थिंक 31 अक्टूबर तक यही है ना, लॉकडाउन ही है ना. हम लोगों को परमिशन नहीं है, कॉलेज स्कूल कॉलेज स्टार्ट करने की परमिशन नहीं. ठीक है, चलो, बाय बाय, थैंक यू.